Algebra 2, Chapter 10, guys. We're skipping ahead a little bit. All right, we are starting Chapter 10 today. So there you go. Chapter 10, Section 1. We are doing this thing called conic sections. We're going to be dealing with circles. We're going to be dealing with ellipses, parabolas, hyperbolas, and you're going to need your graphing calculator. All right, so if you don't have that graphing calculator out right now, you kind of need to get it. Okay, so go ahead and take this moment, pause the video, get that graphing calculator, because we're going to use it through this whole section. Okay, I already said the 4 shapes that you're going to be dealing with: circles, ellipse, parabola, hyperbola, and you're going to be solving for y with all of these equations here. As you can see, first going to solve for y. So you're going to do some basic algebra, solve for y, get the equations set up for y, because then you can plug them into your graphing calculator. Okay, so if you don't have them set up for y, you're not going to be able to plug them in the graphing calculator, and this is going to turn out to be much harder than it needs to be. All right, so let's zoom in and see what we're talking about when I say solve for y. All right, so this is what you're given right there. 16x squared plus 9y squared equals 144. Simply move everything away from y. All right, so what they're doing is they're taking that 16x squared and they're moving it over. That's what gives you the negative 16x squared. Then you're dealing with that leftover 9. So that means everything is divided by 9. Okay, the 9's cross out. That's how you get that 9 right there. And then you got to get rid of that square. Okay, so how do you get rid of that square? By taking the square root of everything. That's what crosses out that square, leaving just y by itself. But don't forget, you got to do plus or minus, because both representations need to be shown. That's what gives you that plus or minus. Then use those 2 equations. When they say 2 equations, they're talking you got a positive and a negative version of the equations. Okay, so positive version right here, negative version right here. Plug that positive in for y1, plug that negative in for y2. That has to be done. You cannot just plug in one of the representations and get the full picture. So you must plug in both parts, positive equation, negative equation, because you're trying to create a full picture. And in this case, this is your full picture. Here's your y1 representing the top half. Here's your y2 representing the bottom half. Now, I want you to notice, you see how it looks like they don't actually connect? Sometimes these graphs don't show it, but they actually do. All right, and so if you just think, oh, it's not actually making a circle, it looks like it's half of a circle, or it's something that just got pulled apart, it does actually complete the circle, but the graphing calculators don't always represent that. That is why you have to go and use the table function in these graphing calculators. Okay, so that's the push second, then push graph. That allows you to access the table function. From the table function, then you're going to be able to see everything necessary. And by that, I mean, you're going to figure out what your intercepts are. You have to use that table. It's going to be much easier that way. Okay. All right. So that's a zoomed in version. Now, when we move on and do the second part of this section, they're going to need us to use 2 equations. One right here is for midpoint. The other right there is for distance. Okay, so they're going to need to give us a point for starters, and then once we have that point, actually 2 points, once they give us 2 points, then we can plug in the necessary values from those 2 points into right here, the midpoint equation, which is going to help us calculate the center of our circle. Okay, a lot of times in this case we're talking about a circle. Then we're going to need to get our distance formula right here, And that distance formula is going to help us to calculate the diameter. All right, so once we're looking at a midpoint, we can help calculate the center point of a circle. Once we have the distance, that's the whole diameter of the circle. And you're going to see us do an example problem where we cover that. Okay, so all that stuff needs to be copied down. Here's an example of finding the center and then the radius, and then that's going to help us calculate the diameter. Okay, so they're going to give us 2 points right there and right there. We're going to need to utilize the x values together. Right here, sorry, the x values 3 and 9 together. And then the y values, that's the 12 and the 4, put those guys together. That's what's going to help us get that midpoint solved for. Okay, that midpoint is going to be utilized to get the center of the circle. Then find the radius. That's the whole distance right there. Okay, once you have that radius, that's going to help us figure out if they wanted the diameter, we could then double that. Okay, if they just want the radius, then we keep it as is. All right, so this is a good problem worked out where they're showing you 2 points, use midpoint, get the center, then use the distance. That's going to give us the radius. We double that. That's going to give us the diameter. Okay, so let's go ahead and do our example problems right here. So step 1 is always solve for y. Step 1, solve for y. That allows us to plug it in to the graphing calculator for y1 and y2. All right, so get that x squared over there, giving us y squared equals 49 minus x squared. Okay, then get rid of the square. Got a square root both sides. That crosses out, giving you y equals a positive and a negative version of the square root of 49 minus x squared. Don't simplify that. All right, I know that we've gone further in this course, and I'd say, oh, 49 does have a perfect root, so does x squared. Leave it. Don't simplify it. Okay, so you're going to plug in 2 versions of this equation right here. Okay, for the y1, let's say plug in the positive version into y1, then plug in the negative version into y2. And the negative version has to have that negative sign, then the radical and everything inside the radical. Okay, so when you plug those into your graphing calculator and then graph it, you should be getting, let's see, you should be getting a graph. It's going to be a circle. Okay, and let's see, when you plug that in, it looks like you're going to be up at about 7, -7, -7, +7, and it's going to make a perfect circle that covers all that. So I'm going to preface this by saying this is hand drawn, and I don't know how good this is actually going to be. So let's see if the iPad can help me here. All right, that's about as good as I'm going to get it. All right, a little help from the iPad. So the center, we have to tell what the center is. And for most all of these problems, the center is going to be 0, 0. So that is one of the values that we have to get is the center, 0, 0. And then you have to tell the intercepts, okay? So the intercepts, when you work those out using the table function, I kind of already jumped ahead and told you, because I've already used the table function for this problem, is that those intercepts are going to be a +7 and a -7 for the intercepts. Okay, so in other words, what we're saying here is you're going to have an intercept at 0 and a positive and a -7. And then on the other side, you're going to have a positive and -7 and a 0. So those are all the intercept values that we're going to get once you solve for y plug it in, graph it, then use the table function. All right, let's just do one more of these just to make sure you guys are grasping the concept. So again, get everything away from the y value. So that means we move the 9x squared over. It's going to be a negative 9x squared. Then we're going to have to divide everything by 25. Okay, and then we're going to have to square root everything to get rid of that square right there. So now let's write it. I know that's a lot of stuff that I just kind of kept putting another layer on another layer. But what we're going to get down to is y is now by itself. And you have a representation of both the positive and negative version of this equation. And you're going to get 225 minus 9x squared divided by 25. And make sure that everything there is actually under the radical. Okay, so that is a square root, and then inside that square root is 225 minus 9x squared, all divided by 25. And make sure if your calculator, especially like mine, I got the TI-83, I have to utilize the parentheses a lot, okay? Because you want to make sure everything is inside and under that radical. Okay, so you go ahead and graph this, but make sure again that you're going to have a y1 is the positive, and for this one, the y2 is the negative version. All right, you have to represent both. So again, the y1 is positive, the y2 is the negative version. Plug that in to the graphing calculator, graph it, and then you're going to get a circle. It's a little bit smaller. Okay, so we're going to represent that as it's going to be a positive 5, negative 5, negative 5, positive 5. So I've gone in, already taken a look at the table function. It's all about 5 and negative 5 for this one. Okay, so let's make our potential circle here. And our intercepts and our center is still 0. Our intercepts, however, are going to be a positive and negative 5. All right, I know I ran out of space, but let's try to show that down here. The 0, 0, otherwise known as the origin, that's my center. All right, and then the intercepts, we'll put them down here. You're going to get a 0, plus and minus 5, and then a plus and minus 5 on that with the 0 there. So those are your intercepts. There's your center of the circle. Okay. All right. So that's example problems 1 and 2 right there on the screen. So you can kind of see it, look at it. All of that worked out there for you. We got 2 more to go. Okay. So for this next one on number 3, again, you need to set it up for y. All right. And then you're still going to have to represent both parts if it has it. So let's zoom in, and you'll notice a negative sign in front of the y squared. We don't want that. That means we're actually going to have to take this, move it over, and the 16 and move it over. So it's a little bit of a double swap here. Okay, that's moving there. That's moving there. Let's rewrite it. X squared now minus 16 is going to equal a positive y squared. You have to get y to be a positive. Let's get rid of that square by taking the square root of both sides. And then go ahead and rewrite this. Positive and negative, square root x squared minus 16 is now equaling y. Y by itself because we took that square root of both sides. Okay, so when we move everything around, that's the equation we're getting. Let's go ahead and plug that into the graphing calculator. And again, don't forget, positive is your y1, negative is your y2. So plug that in because you got to represent both parts. And when you do that, we zoom out a little bit, you're going to actually create a graph that is it's a hyperbola. Okay, so the hyperbola, and it looks like we're at about a -4 and a +4. Okay, and it's going to go like that and then like that. Okay, so that's roughly what the graph should be looking like. Again, don't forget, some of these graphing calculators may actually miss the intercepts. So if they're missing the intercepts, again, you have to use the table function. Okay, so if they don't show this perfect hyperbola where it goes all the way across, that's fine. You didn't do anything wrong, but you have to use the table function to find those vertices. Okay, so what do we have to do here? We have to say what type of conic section we just created. Okay, and the conic section is identifying the name of this shape. Okay, so this is a hyperbola. Okay, and we have to identify also the direction of the hyperbola. And this is a hyperbola that opens horizontally. Okay, so that covered the conic section, that covered the direction. Now we need to talk about the vertices, which the vertices are where it's crossing the x-axis. All right, so the vertices are going to be your plus and -4, 0, because they're not crossing the y-axis at all. Okay, so that covers example problem number 3 right there. Identifying the conic section is naming it. Direction horizontally. Vertices, where is it crossing? In the x-axis or the y-axis, depends on what the graph looks like. All right, let's do our last example problem here. We're given 2 points. We're going to calculate the center, calculate the radius. And that means we're going to have to use the midpoint equation. Let's start with the midpoint equation. Don't forget there's x, y, another color here, there's x, y. So for the midpoint, we have to utilize both x values. 2 plus 14 divided by 2. That's going to give us our x value. Go ahead and put a little comma there. And then our y values. 6 plus 22, divide that by 2. Basically, if you didn't figure it out, you're kind of calculating a little miniature average. Okay, so that's going to get you into that middle point. All right, 2 plus 14 divided by 2 is going to give you 8. And 6 plus 22, that's going to give us a 28 divided by 2. That's going to give us a 14. So this value right here, 8, 14, is the center. All right, so utilizing the midpoint equation to calculate for center. So that's taken care of. Now we have the distance equation that we're going to have to use to calculate for getting our radius, which in return, once we have the radius, could help us calculate the diameter. Okay. So the distance equation, it's a big square root. We got some parentheses, squared, plus sign, and then another set of parentheses. We're going to have to square it. So this is the x2 value, which is 14. In other words, second x value, minus the first x value, which is 2. Then we have our y values. Second y value minus the first y value, which is 6. And then let's go ahead, calculate all of this out. Okay, that's going to give us 12 squared plus, let's see, 22 minus 6. All right, square it. and then you're still going to have to take a square root here, okay? So 12 squared, 44, 16 squared, 256. And we're still going to have to take the square root of that. So you're getting 400 square root of 400. 20. All right. So equals 20. But they're asking, let's see, as a diameter with endpoints. Okay. So if that is our diameter, 20, then if we were to cut that in half, that's going to give us our radius. So radius equals 10. And then this is our diameter. Okay, so now we have all the information there. We have the center of our circle. We have radius is 10, as long as we know, we'll zoom up there, that our diameter is 20. That's it. That covers section 1 today, guys, for chapter 10, talking all about conic sections. So there's example problems 3 and 4, all on the screen, and 1 and 2 right there. All right, guys, ask questions in class if you got them. I'll see you in the next one. Okay.